So this is the Unit 6 quiz, Kinetic Energy, Work, and Power, and this is Form A. I'm going to go through these, starting with number 1. Again, if you don't have Form A, please find this question on your quiz paper. So you might have to go to the next page if it's not on your first page, but you're looking for a question about a hockey player wishing to do work on a hockey puck. And the question says, a hockey player wishes to do work on a hockey puck sliding horizontally on the ice. Which scenario would yield the most work done by the hockey player if their stick is in contact with the puck over the same distance? And your options here are exactly the same except for the angle. And so it's basically asking you at which angle would this hockey player be doing the most work on the puck. And the angles range from 60 degrees, which would be a relatively steep angle like this, to a shallow angle of 15 degrees, which might look something like this. Okay, and so you're basically just comparing in which of these scenarios would he be doing the most work. And we talked about the requirements for work. You have to have a force, which we have. We have 50 newtons of force in all of these examples. And that force has to cause displacement of the puck. It does say that they're going the same distance, implying that there is some displacement, but it's the same. Okay. However, when I say cause that displacement, and technically it's cause or oppose that displacement, we only care about the component of our force that is parallel to our displacement. And so if our entire force was horizontal, then all of our force would get used for displacement of the puck. But they're not. None of these are horizontal. Okay, they're all at angles. And so what you're really looking at is which of these angles has the largest component of force in the horizontal direction, because the displacement of the puck is horizontal. It says it's going horizontally. And so that's all you're looking for, is which one has the greatest horizontal component. And I can tell just by looking at these that this vector here, this component, is going to be larger than this one. Okay, the x component here is relatively short versus this. The closer you get to an angle of 0, if it's 0, it's completely horizontal. But the closer you get to that, the smaller that angle is, the greater portion of it that is horizontal. And so the 15 degrees, since that's the smallest angle, that is the one that you're going to have the greatest amount of work done, because there is a larger amount of that 50 newtons of force, a larger portion of it is horizontal when you're at 15 degrees. And you can do the math if you want and do cosine 15 times that 50 newtons and figure out how much, but you don't need to. You should be able to answer this without any math, and it should be answer choice D. 86% of you guys got that question right, but does anybody have a question about number 1? Again, if you need clarification, if you still don't understand it, today would be the time to ask, because tomorrow you have a test over it, and I don't want you to miss that tomorrow. By the way, if there had been an option of 0 degrees or a completely horizontal force, that would be the best answer. All right, number 2. Numbers 2, 3, and 4 all go with this same scenario. And the scenario says, use the information below to answer the next 3 questions. We have a bar chart, and it says, a ball is thrown downward from the roof of Bridgeland High School for a physics experiment. The bar chart to the right shows the energy of a ball at 2 different points in time during its fall. Assume the ball is in free fall so that there is no air resistance. And so if we look at this first question, it says, based on the data given, what is the net work on the object? Okay, and again, net work is going to be net force times displacement if we have that information, which we don't. Or you should also know that it is equal to, your net work is also equal to your change in kinetic energy. And I do have that information. This is our work energy theorem. Okay, I can see that there is a change in my kinetic energy. If I take a look at my graph, at this initial point, my kinetic energy is 10. At this final point, my kinetic energy is 20. And so the change is 10. Going from 10 to 20, it's a change of positive 10, indicating that I have added kinetic energy to the system and therefore have done positive work. But that change of positive 10 is equal to the work. The answer to number 2 should be C. Questions about number 2? Again, 86% of you got 1, 2, and 3. All 3 of these correct. But not 4. We're going to talk about that in a second, though. Number 3. Number 3 says, if the ball has a mass of 149 grams, how fast is it moving at the final point shown in the graph? Okay, and so it's asking about this final position. I can see the kinetic energy at the end is 20. Okay, at the end. And so based on that kinetic energy that I know, 20 joules, I should be able to determine how fast it's going, because we have this equation that says that KE is equal to 1/2 mv squared. And so I have 20 for my kinetic energy, and I can set it equal to 1/2 times the mass times the velocity squared, and I can solve for the velocity. Okay, the mass is in the question, 149 grams. However, if you plug in 149 grams, you will get the wrong answer. And some of you probably did that, and that's why only 86% of you got it right, in all likelihood. You cannot use grams in these calculations. We talked about it in class. We did examples like this. If you see grams, convert it to kilograms. There are 1,000 grams in a kilogram, so 149 grams is 0.149 kilograms. And so that's what it looks like after substitution. Okay, so I'm going to get half of that 0.149. And then we're going to divide both sides by that number. So 20 divided by that number. And this is equal to v squared. Not v squared. So if I want v, I'm going to take the square root of that number, and the velocity that I get is 16.38 or 16.4 meters per second. The answer should be D for number 3. Number 4. Number 4 was the most missed question. For y'all, it's actually tied for most missed with one of the other ones, but it is one of the most missed questions. Okay, I think it was the most missed question overall in all of classes. It says, which of the following is or are responsible for the work done on the ball during its fall, while it is falling? Okay, and I know that work is force times displacement, so I know that I need to determine what forces are acting on the ball during its fall. I just heard O. Some of you just figured it out, because the most common answer to this was C. And that's wrong. C says both A and B. A and B. A says Earth's gravitational field, gravity. B says the person who threw the ball. C says both of them. D says there is no work. It's not D. It's not C either. It's either A or B. Okay. During the fall, okay, it's just gravity. While it's falling, it's just the gravity that's acting on it. And it says it up here too. It's in free fall. If you're in free fall, by definition, that means the only force acting on the object is gravity. So yes, that person did throw it. Yes, there was an initial force. And yes, if the question had asked while the person is throwing the ball, yeah, you'd pick this. Because as he is actively pushing that ball forward with his hand, he is doing work on the ball. But once it stops touching his hand, he is no longer applying a force to it. He gave it an initial push, but now it's just falling. And so when it's in free fall, the only force acting on it during its fall is the force of gravity. The answer to number 4 should be A. And again, this would only be true, the person who threw the ball. You'd only have work being done by that person during the throw. Okay, not once it leaves his hand. Okay, so the answer should just be A. And as I said, most of you who got it wrong picked C. Are there any questions about that? Does that make sense now that we've gone over it? Okay. Number 5, 82% of you got number 5 right, so that's good, especially since this is one with an angle in it. That's pretty good. If you missed it, obviously listen up, but it says you pull your friend in a sled with a constant force of 102 newtons. I'm going to go ahead and label that on my picture. 102 newtons at a 30-degree angle with respect to the ground. You pull for a distance of 57 meters. How much work did you do? Ignore friction. So, whenever you look at this, the work, again, is force times displacement. Okay, but when you use this equation, you can only do this if the force is in the same direction or parallel to the displacement. So you would have to find the component of the force, this component right here specifically because it's moving horizontally across the ground. You got to find that piece. It's not 102. It's a portion of it. Okay, or you could just use that dot product equation, FD cosine theta. Okay, you could do that instead and multiply it here. But regardless, when you do this force times cosine theta, you are finding that x component. Okay, you can do it all in one step like this, or I can find the component and then multiply it by the displacement. It's the same thing mathematically. Okay, so if I want to do this, I'm going to take that 102 newtons, I'm going to multiply it by the displacement, 57, but then I also have to multiply it by cosine of the angle, 30 degrees. And when I do this piece right here, 102 times cosine 30, I am finding this and multiplying that by the displacement. So again, you can do it in 2 steps, or you can do it all right here in 1. Okay, but just be really careful and make sure you don't forget to multiply by the angle if you're using the number from the question. And make sure also that you're in degree mode on your calculator. Okay, otherwise you'll get it wrong. All right, so 102 times 57 times cosine of 30 degrees gives me this number, 5,035.07, which is rounded to 5,035. On the answer choices, that is B. I think if you had used the whole 102, you end up getting A. And let's see if people picked that. Yeah, the people that missed it, 3 of them put A. 2 people forgot to bubble it. I don't know if you skipped it and thought you were going back to it or what. Questions about number 5? All right, number 6. Number 6 says an 8-kilogram box is pushed 0.5 meters with a force of 50 newtons. How much work is being done on the box? Ignore friction. This one's even easier than the previous one. There's no angle. If all you have is a force being applied, and it really should specify here that that force is horizontal and moves the box horizontal, it needs more information. But based on what you have here, it's a safe assumption to assume when it doesn't say that the force is in the same direction as the displacement, but we should really clarify for you. That said, I don't think it really tripped anybody up because every single one of you got it right. Okay, so all you had to do here was force times displacement. Your force was 50, your displacement was 0.5. 50 times 0.5 was 25. The answer to number 6 was D, and as I said, every single person got that right. Number 7, though, was the 3rd most missed question. Okay, so if you missed questions, odds are that one of them was number 4, and there's pretty good chance that one of them was number 7. Okay, so listen up. Number 7 is about a roofer climbing a ladder. So if you're not on Form A, you might want to find this one, see if you missed it. But it says, a roofer climbs a ladder carrying a 3.6 kilogram box of roof shingles. If it takes him 17 seconds to carry the box up the ladder from the ground to the roof, 5.2 meters above, how much work does he do on the box? Okay, my last class got thrown off because they saw this word carrying and they said 0. And maybe some of you did too, I don't know. Okay, and that is, we talked about this in class because there are lots of scenarios where somebody carries a box across a room, and you're absolutely right, that's not work. Because if you're carrying a box across the room, your force is upward, but your displacement is forward. They're perpendicular to each other. However, if you're carrying something upstairs or up a ladder or you're going up, well now guess what? You're applying a force upward to support the weight of this box, but you're also moving upward. So this is work, okay? If you're climbing and carrying something while you climb, that's work. Whether it's stairs or a ladder, whatever it may be, because now my force and my displacement are in the same direction. They're parallel. It's not the same as carrying it across the room. Okay, so make sure you read the scenario. Don't stop when you see the word carrying and say, oh, it's 0. Okay, so let's talk about what that force is. So if you're carrying something up or lifting something from the ground, if I lift this calculator, okay, the force that you have to use to lift something or to lift it at a constant rate is equal and opposite to its weight. So we need to figure out what that force is, because if I'm trying to figure out how much work was done, I need the force and the displacement. And if the force is equal to the weight, then I need to figure out what the weight is, because weight, of course, is a force. It's mass times gravitational acceleration. And so even though this question doesn't tell me how much force he uses to carry this, because they give me the mass of it, I can figure out its weight and thus the force I would have to use to lift it. Okay, and we talked about these examples in classes. We had like somebody lifting a barbell and different stuff. Okay, so if you're lifting something, even if it's yourself, the force you have to use to climb stairs would be equal to your weight. Okay, so you'd have to find the weight of whatever the object is, whether it's your own body weight or you're lifting a box. All right, so mass is 3.6. We're going to multiply 3.6 times 9.8. That's going to give us the force. So 3.6 times 9.8 gives me 35.28. And so that's going to be my force. So when I go to find the work, I'm going to use 35.28 as my force, and I'm going to multiply it by the displacement. Again, it's up. We're carrying it up a ladder. So the fact that the roof is 5.2 meters above, that's how high we're going, 5.2 meters. So we're going to multiply the weight of that box of shingles by the height that we're carrying it to, and we're going to get 183.456, or on here it's rounded to 183.5. It's answer choice D. So again, if you're lifting or carrying something upward, please find the weight, that will be your force, and then multiply it by the distance, which will be the height that you're carrying it to. Are there any questions about number 7? Any remaining questions? Hopefully that clarified it for you, because only 44% of you got that one right. That's why I said it was heavily missed. I don't know if it was better for the campus. Let's see. Number 7. No, it's 39. So y'all did slightly better than the average, but I don't know that it's anything to brag about. Okay, we want to make sure we don't miss that tomorrow. So if there's anything where somebody's lifting or something up, or even their own body, if they're climbing stairs, make sure you find their weight, okay, or the weight of the box. All right. Number 8, you are looking for this graph. It is a force position graph, and it says, the graph below shows the force exerted on a ball falling with negative velocity as it is caught in a net. What is the change in kinetic energy of the ball as it moves for 24 meters? So I can find change in kinetic energy, so delta KE. I can find that if I know my final kinetic energy and my initial kinetic energy. I can subtract. I don't know that. I also can find it if I know work, because change in kinetic energy is equal to work. That is the work energy theorem. And I do have enough information to find that, because work is force times displacement. And this is a force position graph. Force displacement graph, change in position is displacement. And so if you are in a situation where you're trying to find something and it's on the axes of your graph and you are multiplying, if you are multiplying your x and y axes, find area, which means I just need to find the area of the shapes on this graph. And I want the whole graph because it says 24 meters. That's the whole thing. So I need to find the area of this triangle, and then I need to find the area of this rectangle, and I need to add them together. that total area is going to give me my total work, and that will be equal to my change in kinetic energy. So if I take a look at that, the area formula for area of a triangle is 1/2 base times height. The base of this going across the bottom is 12. The height is 42, so it'd be 1/2 12 times 42, or 6 times 42, since that's half of 12. And 6 times 42 is equal to 252. So the triangle has an area of 252. The rectangle, on the other hand, length times width, we're just going to go across the bottom. That's going to be 12. Go up this axis, that's 42. 12 times 42 is 504. And we're going to add that 504 with our 252 to get a total area of 756, which is our answer, 756 joules. Again, if I find the area, I have found work, and work is equal to change in kinetic energy. So the answer should be B. Are there any questions about number 8? All right, number 9 on Form A has a different type of graph. This is a work time graph. And the question says, which of the following, or sorry, not that. The following graph displays the work versus time of a small motor on a toy car. What is the average power of the motor from 0 to 4 seconds? So this graph, we looked at the whole graph. This time, though, we're only looking at the first 4 seconds. Okay, so make sure you pay attention to which part of the graph you're looking at. The question is asking us for power, and our equation for power is work divided by time. Okay, that's what's on my axes, work, time. Anytime you are dividing y by x, change in y over change in x is slope. So if I want to find this one, I'm going to find slope. This one, my equation was multiplying them, so I found area. If I'm dividing them, I'm finding slope. Okay, rise over run. And so it doesn't actually matter in this one that we're only looking at the first 4 seconds, because the slope is the same the whole time. I just need to pick 2 points on that line. Since it's a straight line, any 2 points will work. But I'll go ahead and use that point and my origin. Rise over run, change in y 40, change in x 4. 40 divided by 4 is 10. The answer to number 9 should be C, 10 watts. You guys did pretty good with this one. This one you struggled with a little bit. Only 68% of you got the previous one right, but this one was 89%. Okay, so make sure you look at those graphs some more if you need to. Questions about either 8 or 9? Okay. Number 10 on Form A is about Sally pushing a box. And number 10, only 2 people missed it in this class. It says, Sally pushes a 25 kilogram box with 100 newtons of force to the right. The box moves to the right 20 meters. Friction opposes the motion with a force of 50 newtons. What is the net work done on the box? Again, if I ask you for net work, you can either find how much work Sally does and then find how much work friction does and then get the total work. Or get the net force. Again, net work is net force times displacement. That's a little easier. And to get net force, I'm going to start with a free body diagram. Okay, so here's my object, and I know Sally is pushing with a force of 100 newtons to the right. So here is my 100 newtons to the right. I know that friction is opposing that with 50 newtons to the left. So here's my 50 newtons to the left. Okay, my net force is the sum of my forces, keeping in mind that forces are vectors. This is negative 50. It has a direction. So when I add them, my net force is 50 newtons. And if I want to find my net work, it'll be my net force, F net, times displacement. And that's going to give me my net work. So I'm going to take this 50 newtons, I'm going to multiply it by the displacement, which in the question says is 20 meters. And so we're going to do 50 times 20, which is 1,000, and it is in the positive direction. Everything's to the right, so it's positive 1,000, and that's answer choice A. Okay, because I multiplied a positive number times a positive number. My force and displacement were in the same direction, therefore I get positive net work. Questions about number 10? Again, I'm assuming y'all are good with it because, as I said, only 2 people missed it. But if you're one of those 2, make sure you know why you missed it. All right, number 11. Number 11 was the other most missed question. I told you that there were 2 of them that were tied. This is the other one. Okay, so if you missed questions, it's likely that it was this one, number 4, and number 7. Number 11 says, during a physics lab, Jack and Jill ran up a hill. Jack is 4 times as massive as Jill, yet Jill ascends the same distance in half the time. Based on this, blank did the most work and blank delivered the most power. Okay, and so this is asking us to look basically at proportional reasoning. What is the effect of changing the mass? What is the effect of changing the time? Okay, and we're just trying to figure out who does more work and who does more power, or who has more power. So work is force times displacement. Power is work divided by time. So, taking a look at this, work only depends on force and displacement. So the fact that Jill does it faster doesn't affect the work at all. That has no effect on work. It does play a role in determining power, but let's talk about work first. Work is dependent upon the force and the displacement. They're climbing the same hill, they have the same displacement. Okay, if they both start at the ground, they both get to the top, they're both the same distance away from where they started. Okay, however, they don't have the same force because, as I mentioned already, if you are climbing something, whether it's a hill or stairs or a ladder, the force you have to use is equal to your weight. And it says here that Jack has 4 times as much mass. If he has 4 times as much mass, he will have 4 times as much weight, which means he will have to use 4 times as much force to get to the top. And when I look at this, that means that if I have 4 times bigger value here for F, I'm going to get more work. And so Jack does more work than Jill. So I can eliminate B and C right off the bat. It's either A or D. Looking at the second part, who has more power? Jill does do it faster, and power does partially depend on time, but it also depends on work. Their work wasn't the same. Jack had 4 times as much work. Jill, because she does it in half the time, would have 2 times. That would be the effect of that on the power. Okay, I think we all agree that 4 is a bigger factor than 2. And so even though she does it faster, it's not enough to overcome their weight difference. He is still using 4 times the force and therefore has 4 times the work. She would have to run 4 times as fast. She'd have to do it in 1/4 the amount of time just for it to be equal. Okay, and so the one with more power is also Jack. So the answer is D, Jack, which makes me think of the character on The Incredibles, the baby. Yeah. Questions about number 11? All right. Again, even if you missed it, hopefully you understand why now so that you don't make a similar mistake on the test if there is a similar question. Number 12. Number 12 says, the Incredible Hulk pushes on a wall with 50,000 newtons of force and the wall does not move. How much work did the Hulk do on the wall? And none of you fell for it. Everybody got this right. There are only a couple of criteria for work to be done, but one of them is you have to have displacement. If it doesn't move, the answer is 0. A. Every person got that right, so good job, guys. Number 13 says Napoleon has a mass of 100 kilograms. He jumps out of a plane and pulls his parachute. At the time he pulls his parachute, he has 2,000 meters to reach the ground. The air resistance against the parachute is 800 newtons. What is the net work done on Napoleon as he descends to the ground? Again, net work means that I need to find net force. And if I need to find net force, it's a good place to start by drawing a free body diagram. So I know that there is an air resistance against the parachute of 800 newtons. So I know that I have this upward force of 800 newtons. However, Napoleon is still falling, okay? And if you're falling, and even if you're not, if you're on Earth, you have to also include your force of gravity, his weight. So I need to also include Fg. And I can find Fg, even though they don't give it to me, I can find it because it's mass times gravity. His mass is 100 kilograms. I'm going to multiply that times 9.8, and I'm going to get 980 newtons. And so if I'm trying to find net work, I first need to find net force. Well, these are my forces. Again, net force is the total force. We're going to add them, keeping in mind that they're vectors. This one's down. I'm going to label it with a negative sign. Okay, so my net force would be 800 plus negative 980, or 800 minus 980, which of course is going to give me F net of negative 180 newtons. And so if I want to find net work, I'm going to have net force times displacement. My net force, negative 180. My displacement, he is 2,000 meters from the ground. He has to fall 2,000 meters. His displacement is negative 2,000. And because his force, his net force, and his displacement are both down, I'm going to get a positive number. Negative times a negative is a positive. Again, if your force and your displacement are in the same direction, you will have positive work. Negative 180 times negative 2,000 gives me an answer of positive 360,000 joules. The answer to number 13 is A. 82% of you guys got that one right, so y'all did pretty good on it. But does anybody have a question about number 13? All right. Let's take a look then at number 14. You need to find this graph in order to find this question and see if you got it right, although I'm going to tell you right now you got it right. Nobody missed it in this class. It says, examine the force versus displacement graph. What is represented by the shaded area on the force versus displacement graph above? And again, we've already done this. If you're finding area, it means you are multiplying the values on your x and y axes. That's what it means. Area means multiply. And so force times displacement is the equation for work. Therefore, work represents the area underneath that curve, or line in this case. The answer to this is B for number 14. All right, and I'm assuming y'all don't have questions since everybody got it right, but if so, please stop me before we keep going. All right, number 15, 89% of you got this one right, so you guys did pretty good on it. It says, choose the scenario that will increase the amount of power produced. And so just as a reminder, power is work divided by time. And if we read the answers, it says work is doubled, time is doubled. Well, guys, if I change both of these by the same factor, not going to change my power. So it's not going to be A. It's for the same reason it's not going to be B. If they're both the same factor, it's not going to change. Okay, so it's either C or D. We're looking for the one that will increase our power. C says work is doubled, time is halved. Yeah, that's going to increase my power by a factor of 4. Okay, so this is my answer. But let's read D. Work is halved, time is doubled. That's actually going to make the power smaller by a factor of 4. So we don't want to pick that one. The answer we want to choose is C for number 15. And as I said, only a couple of you missed it. Make sure you read it carefully. Those of you missed it picked A. Questions about 15? All right, number 16. Number 16, 79% of you guys got right, so there were a few people who missed it. It says, in which scenario is negative work being done by the student on the box? So again, remember, you have work that's negative if the direction of your force and displacement are opposite. If they're in the same direction, you're going to have positive work. So this one says a student raises a box over their head. If you lift a box, your force is up. If you raise it over your head, your displacement is also up. They're both in the same direction. It's not going to be that one. B says a student lowers a box from over their head to the ground. You're still going to be supporting the weight of the object. If you pick something up like I'm doing right now with my calculator and I lower it, I'm still pushing up on the calculator, but my displacement is down. And so in that example, my force and my displacement are opposite, and this is the answer to the question. But let's read the other two just to make sure. It says a student pushes a box to the right, it moves to the right. Again, same direction. This one says a student pushes a box to the left and it moves to the left. Again, same direction. If they're in the same direction, okay, then you will have positive work. The only one where the force and the displacement are in opposite directions is answer choice B. Questions about number 16? All right, number 17, 71.4% of you got this one right. So you did miss this one. The wording on it is a little strange. I will say that about it, but I think it's in my open math as well, if I recall. There was one just like this. So you've seen it before, even though the wording's kind of weird. It says, if a wagon is being pulled with 0.4 times the force for 5 times the distance as it was originally pulled, how much work is currently being done? So we're just looking at proportional reasoning, and we're looking at the relationships between these variables and what changing them does to the work. So you need to look at the equation in order to answer this. Work is force times displacement. And so if you have 0.4 times the force, if you have less force, okay, but you have more distance, okay, and you can put those factors in, 0.4 times for the force, and for the displacement, I have 5. You can literally just multiply them together, okay, and figure out what factor it's going to change by, because this one's 0.4 times as much, this one's 5 times as much. If you multiply 5 times 0.4, you're going to get 2. The answer to this is twice as much. Okay, so just multiply them because each of them has a direct relationship with work. But go back to the formula for that. All right, last one, number 18, 79% of you got it right, and it says, in a scrimmage against his players, a soccer coach at Bridgeland High School scored a goal. If the coach uses 1,150 newtons of force to run and he travels 12 meters to the ball at a speed of 9.2 meters per second, how much power was needed for him to score? So again, power is work divided by time. However, I don't have those pieces of information. So I know that work is force times displacement. So I can rewrite this equation as force times displacement over time. But again, I still don't have all those numbers. However, if I look at this, displacement over time is velocity. That's the definition of it. It's also the formula for it. So I can rewrite it again as force times velocity. We did this in class. It was in the notes too. But in order for us to answer this question, we need to know that power isn't just equal to work divided by time. Power is also equal to force times velocity. That's going to make your life a lot easier when you're trying to answer this question. Could you do it the other way? Yeah, you could do it the same way I did it in class. But this is easier. So again, force times velocity is going to be 1,150 times a velocity of 9.2. And if we multiply those out, 1150 times 9.2, we get 10,580, which is right here, answer choice C. Questions about number 18? All right, guys, so here's the deal. The quiz is fairly similar to your test. However, the quiz kind of didn't really cover work energy theorem very much. It was just kind of barely on there. Kinetic energy, same thing. So in addition to looking at this quiz as a source of review for you, I'm going to also strongly encourage you to look back at some of the warm-ups, and I mentioned this last week as well, like from the 4th, 5th, 8th. Look back at those warm-up questions, this one about the paper cup falling, and you can go to my slides, or you can go, this is the videos that are posted in the YouTube playlist from the notes every day, but you can look back at these videos. So if you want to hear me go through the warm-up, or you can go to the slides and click through the warm-ups. But I would look at them because this is the type of question that we didn't really cover as much on the quiz as we maybe should have, because you're going to have some like it on the test. Remember, your test also has a bonus question, and I would strongly encourage you to look over these warm-ups to help you with that, because it's the same type of thing you're going to see. Okay, so again, the 4th, the 5th is the similar one. It's the same type of question, except it's asking it in a little bit different way. It's asking you about the air resistance. Okay, so I definitely encourage you to look at this, or again, the 8th. By the way, if you haven't looked at the playlist, again, you don't have to go back and watch the notes again, because y'all get them in class. But don't forget, at the end of the playlist, there are also these videos where I go over the problem sets. So those have been there. They've been popping up like a day after the problem set has been assigned, so that you can't use it to do the first time, but it shows up before the late deadline passes. But you can use these if you had any questions with those. In addition, don't forget that you have that mixed work and power mixed review. If you didn't do that, it is a daily grade redo, but that doesn't mean it's an optional assignment. It's in the grade book, and some of you right now have a low grade for it, so please go finish it. You can use a late pass until 11:59 p.m. tonight, but it's also a good review. So do it not just for the review, but also it's a daily grade. It is also a daily grade redo. Okay, so please don't forget that that's there. Use it to help you study. Go back and look at these to help you study. Go back and look at the warm-ups to help you study. Or open up this quiz later on whenever you get home. Regardless, you guys have a test tomorrow, so don't forget to study.